Good morning, dear students. Today we will start learning about inertia and mass. After that, we will cover second law of motion. These two topics we'll cover today. So let us begin. So in this previous classes, we were discussing about inertia. Mass, what is mass? You already know what is mass. Now, what is inertia? Inertia is a resistance offered by an object to change its state of motion. In the previous class also I explained you about inertia, that if an object is at rest state, it will try to remain in the rest state. If it is in motion, then it will try to be in motion. Okay, so this resistance offered by the body, that is called inertia. So a resistance offered by an object to change its state of motion is called inertia. If it is at rest, it tends to remain at rest. Suppose a body is at rest position, it will remain at rest position. It is not going to move. Okay. If it is moving, it tends to keep moving. Suppose this body is moving in this direction, it tends to move. Suppose there is no external force which is applied on the body in the opposite direction, like friction and all that, all those forces, so this body will keep on moving. Okay, so this is called inertia. So if it is moving, it tends to keep moving. This property of an object is called inertia. Okay, so you can say that inertia is a property of an object through which it will always try to be or to continue in its state of rest or state of motion. Now, do all bodies have the same inertia? Okay. The inertia of an object is measured by its mass. So, as inertia is measured by the mass, so the answer of this question, that is, do all bodies have the same inertia? This is no. Why? Because inertia, it depends upon mass. More is the mass, more will be inertia. So suppose there are two bodies. Suppose there is a car and there is a bike. Mass of the car is much more than mass of the bike. So inertia of the car is also more than inertia of a bike. Okay. So you can easily move a bike, but you cannot easily move a car from outside. You cannot, one person, you cannot you cannot push a car from outside and make it move. Okay, it is very difficult. Next is inertia is the natural tendency of an object to resist a change in its state of motion of rest. So it is a natural tendency of an object. Here it is the same definition, that it always try to resist a change in its state of motion or rest. That means if the body is at rest position, it will try to remain in rest position, and in case of motion also. The mass of an object is measured of its inertia. With respect to mass, we can measure the inertia. In the coming classes, we will see with respect to mass how we are going to measure inertia. Okay. So, second law of motion, which is very important. First law we have already discussed in the previous classes. If you have not watched, then please watch the video. So the second law of motion states that the rate of change of momentum. So here the word momentum. What is momentum? First we need to understand. And what is the rate of change of momentum? Momentum is nothing but the product of mass and velocity. The mathematical multiplication of mass and velocity. Suppose a body of mass 5 kg is moving with a speed of 10 meter per second. So what is its momentum? 5 into 10, 50. Okay. So 50 kg meter per second. So its momentum, its unit is kg meter per second. Okay. So then what is the rate of change of momentum? Whenever the word rate comes into picture, it is related to time. Okay, suppose a body, this is a body which is moving from point A to point B, and it is accelerating. Suppose the speed of the body is increasing, or the velocity of the body is increasing. So at the point A, the velocity is body is 10 meter per second. At point B, the velocity of body is let 20 meter per second. From point A to point B, suppose the body needs 5 second time. Okay. Now mass of the body is let 500 kg. 500 kg. Okay. So what is the momentum of the body at point A? Momentum body of the body is 500, that is mass, into velocity 10. 500 into 10, that is 5000. At point B, 500, here also mass of the body will not change. 500 into 20, that is 10,000. So here momentum of the body is 5,000. Here momentum of the body is 10,000. From 5,000 to 10,000, what is the time required? That is 5 seconds required from to cover the body from point A to point B. So the rate of change of momentum is nothing but the difference between these two momentum divided by time. Okay, that is called a rate of change of momentum. Okay, that rate of change of momentum is difference in momentum between 2 points divided by difference in time between 2 points. Okay, that is rate of change of momentum. So the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now this rate of change of momentum is proportional to the applied unbalanced force. So why it is unbalanced for, why not balanced for? Because in the previous classes we learned that unbalanced force is the force which makes the body move. If you apply balanced force on a body which is in rest position, the body is never going to move, because balanced force is not able to overcome the friction, overcome the frictional force. So if you apply more force, more unbalanced force in the direction of motion, so the rate of change of momentum is also more. It is very easy. Suppose you take a stone, small stone, piece of stone, you throw it with very little amount of force. It will slightly move, gently move. You throw it with the maximum force that you can apply. It will move speedily. So the same mass is moving with different speed. Okay, so mass into, in first case the velocity is small or the speed is less, so in first case the momentum is less. In second case, if you throw it with a very high force, then the body is going to move with very high speed, so the momentum is also more. Okay, second point, the impact produced by the object depends on their mass and velocity. Okay, this point is also important. The impact produced by the object depends upon the mass and velocity. Suppose here we consider two object. Okay, uh, first one is bike, second one is truck. Okay. Suppose both the bike and trucks are moving with the same speed. Okay, now there is an accident. Okay, uh, suppose there is a small house. Okay, now while moving, the bike rider, he or she could not control the bike, and there is accident between the bike rider or the bike and the small house. So what will happen? Nothing is going to happen to this house. The house will remain as it is. But with the same speed, if there is an accident between the truck and the small house, then what will happen? Think. Okay, so here, as the mass of the truck is more than the mass of the bike, even if they are moving with same speed, the impact will be more, because in case of truck the impact is more, in case of bike the impact is less. Okay, now this is the example where two different bodies having different mass were moving with same speed. Okay, now if we consider a particular object having same mass moving with different speed. Now suppose this is a bullet. A bullet is fired. Now suppose two bullets of same size, same mass, everything is same, are fired with different gun. Okay. Now first bullet is moving with certain speed, let 100 meter per second. Now second bullet is moving with 500 meter per second. Okay. Now, as this bullet is moving with 100 meter per second, the impact of this bullet will be less compared to this one. It is moving with 500 meter per second. Let us give me some more example. Suppose you have a stone. This is a stone. Mass of the stone is, let's say, 100 gram. 100 gram. This is your friend. You had a quarrel with your friend. So what you did, you pick up the stone and throw it towards him very gently, like you are doing a joke. In this case, what will happen? Nothing is going to happen to your friend because the speed of the stone is very slow. Okay, he or she is most probably going to catch it. On the other hand, on the other day, you are very angry and you pick up the stone and throw towards him with a full force that you have. Now, what is going to happen? Your friend is going to get hurt. Now, the mass of the stone is same, but in two different cases, the speed of the stone is different. Okay, so if the same body or the bodies having same mass, they move with different speed. The more is the speed, the more will be the impact of its motion. Okay, so the impact produced by the object depends on their mass and velocity. Next point, the momentum is represented by the letter P. Okay, momentum, mass into V. This is represented by the small letter P. Of an object is defined as the product of its mass and velocity, that is P equal to mv. This one I have already told you. Since the application of an unbalanced force brings a change in the velocity of the object, it is therefore clear that a force also produces change in momentum. So as because due to the application of unbalanced force, the body is moving. Why the body moves from rest position? Due to the application of unbalanced force only. So initially, if we consider an object lying on a particular table, so initially the object is at rest position. Rest position means its speed or velocity is zero. So its momentum, that is mass into velocity, is also zero. Momentum is also zero. Why? Because velocity is zero. So mass into zero is zero. So initially the body is having zero momentum. Now, when an unbalanced force is applied on the body, it start moving, it start rolling. So from zero momentum, it is achieving certain amount of momentum. Why? Because of the applied unbalanced force. So we can say that since the application of an unbalanced force bring a change in the velocity of an object, as because of unbalanced force is applied, the velocity of the object is changing, it is therefore clear that a force also produces change in momentum. So here, due to the application of force, the momentum is changed. That is, momentum is changed from zero to certain value. So due to the application of unbalanced force, the momentum may change. We conclude it like this. It means that change of momentum of the object is not only determined by the magnitude of the force, but also by the time during which the force is exerted. So here what happens? Here it is saying that a body is in certain position, maybe rest, maybe motion, does not matter. So when a force is applied on the body, the momentum is going to change. When the unbalanced force is applied, the momentum is going to change. This much we have understood. Now, for how much time the force is going to apply, that is also important. Okay. So, for example, now this is a stone. You are trying to push the stone. Now, For 1 second, if you try to push the stone, is a big one, the stone might not move. It may not move. Let me draw the diagram properly. Suppose this is a stone. This is you. So when you try to push the stone, you may not be able to move the stone if you push it for just for 1 second or 2 seconds. If you keep on applying force, then there is a high possibility that the stone might move. Okay, so the time for which the force is applied, that is also important. Whenever an unbalanced force is applied on the body is going to move. That means it is going to acquire some momentum. Now, for what time the force is applied, that also determines the momentum. It means that the change of momentum of the object is not only determined by the magnitude of the force, but also by time during which the force is exerted. So momentum depends upon two factors. First one is what is the value of unbalanced force? Unbalanced force. For what time this unbalanced force is applied on a particular body. These two factors will determine what will be the momentum of the body, provided mass of the body is known to you. Okay, if the mass of the body is not known to you, how will you calculate it? Okay, now the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed. So this is also the same thing. For what time the force is applied, that is the time rate. Okay, now there are certain mathematical formula. So we'll consider an object. So here we'll consider an object whose mass is m, initial velocity is u, F is the force, unbalanced force, which is constant, whose value is constant. Now this force is applied for time t. Okay. Now this is an object. Mass of the object is m. It is moving with initial velocity u. Okay. Now here F force is applied on the object for t time. Okay. So when this force is not applied on the body was moving with u velocity. So what is the momentum? M into u. After application of force, let the speed of the body changes to v. So after the application of force, as the speed changes, so what will be the momentum? M v. Before application of unbalanced force, it is mu. After application of unbalanced force, it is mv. So what is the change in momentum? This minus this value, this is p1 we consider, this is p2. So change in momentum is equal to p2 minus p1. Okay. Now it is directly depending upon this one, because initial and final momentum, the momentum will be p1 and p2. The change in momentum is directly proportional to p2 minus p1. Okay, now at this particular time the change in momentum is equal to p2 minus p1. Now it will also be, because for the constant force the change in momentum will be directly proportional to p2 minus p1. Okay, now if you put the value mb minus mu, then you take m mass common from here, m into in bracket v minus u. Now the rate of change of momentum, what is rate? When this rate comes, we divide time. We divide time here. Okay. So the rate of change of momentum m into v minus u divided by time, or the applied force. Okay. So here in the previous slide we saw that force, the rate of change of momentum also proportional with the applied force or unbalanced force. More is the force, more will be this value. So we can say that force is proportional to this value, rate of change of momentum. So if force is proportional to rate of change of momentum, we can include a constant here, k. Okay. So F equal to k into m into v minus u divided by t. Now you can see what is v minus u divided by t. We have learned an equation that V equal to U plus AT. From this you can conclude that A equal to V minus U divided by T. So this is V minus U divided by T. In this place we can write A. So F equal to K, that is constant, into mass of the body, that is m, into acceleration. Now if we consider the value of the constant is 1, remember it is not always 1, we are considering this is a constant. So 1 is a constant, so we are considering it to be 1. This value could be any other value also, it could be any other value. So if k is equal to 1, then in this case mass force equal to mass into acceleration. So the second law of motion gives us a method to measure force acting on an object as a product of its mass and acceleration. So from the second law of motion, we conclude that whatever the unbalanced force applied on the body, the value of that unbalanced force is equal to product of mass of the body and the acceleration of the body. Okay, for k is equal to 1. Okay. There are some examples. These examples are very important. From these examples, question will be asked in your exam. So, while catching a fast moving cricket ball, see here, remember one thing, the cricket ball is moving fast. A fielder in the ground gradually pulls his hand backward with the moving ball. Okay. So here, this is a cricket player. The player catches the ball and he or she moves her hand in the downward direction or in any other direction. Why? Because as we know, as we just studied, that the impact of the momentum depends on time also. Okay. So here, when the ball hit his hand, if he is not going to move his hand, so for a very small interval of time, the ball is going to hit his hand. Okay. Now, within a very few seconds, the ball is coming to rest position. So, whatever the energy of the ball will be directly transferred to his hand. So, here, while moving his hand, what he is doing, that he is increasing the time in which the energy of the ball will transfer to his hand. So, the impact of momentum will be less. Okay. So, while catching a fast moving cricket ball, a fielder in the ground gradually pulls his hand backward with the moving ball. In a high jump athletic event, the athletes are made to fall either on a cushion bed or on a sand bed. So, in your school, in the sports, you might have seen that whether it may be high jump or long jump. So, suppose this is an area where students are running for high jump or long jump. In that area, sand may be there, or some cushion may be there. Why? Because when you run and from this before this line, when you jump, if a very hard surface is there, so the contact of the contact of your leg and your the surface is very less. So through this time, all the energy of your body will transfer to the surface. So as a reaction, the body is going to transfer the same energy to your body. So there is a high possibility that you might get hurt. Rather, if this hard surface is replaced by a smooth surface, then the time so when you jump on the surface, when you jump onto the surface, the time through which your energy is going to transfer to the surface will increase. So the return energy that the surface is going to you will be less. Okay. So you will not get harm or you will not get hurt. A karate player breaks a slab of ice with a single blow. What is the reason? Suppose this is a ice. This is a piece of ice. Okay. It is kept like this. A karate player is able to break the ice. Why? Because he is applying the same amount, he is applying force. But the time of transformation of the force from his hand to the ice is very small. So whenever the time of transformation is very small, the impact of the force is very more. So when the very much. So when the impact of the force is very much, so it is going to break down. Okay, because of the transformation of momentum. So here we saw in these examples that how time can decide the things. Okay, so if time is more, if time of contact between two body while the energy transformation is more, then the impact will be less. If the time is less, impact is more. So these are some of the examples. So this is all about today's class. In the next class, we will start mathematical derivation of first law from second law. Okay, so thank you and have a nice day.